All right, so on this one, we're going to find the slope of the tangent line to the graph of the function at the given point. So what do we know? We know that our function is negative 2x plus 7. Okay? And then we're going to finish this thing out by finding the tangent line at negative 1, 9. So we're going to do the limit process. So the limit as h approaches 0 of f of x plus h plus 7 minus f of x, which is the original function, watch your signs, all over h. So we're going to distribute on the top. So the limit as h approaches 0 of negative 2x minus 2h plus 7 plus 2x minus 7 all over h. Okay, and when we simplify, this is going to reduce with this. This is going to reduce with this. And we're left with a negative 2h over h. Well, then your h's reduce. So now we're left with the limit as h approaches 0 of negative 2. Okay, so what does that mean? That means your formula for slope is negative 2. So come back up here, and this is what we said in the last video. That's a line. Your slope is negative 2. So we didn't have to do everything that we just did because your slope is negative 2, which means the equation of your tangent line is a negative 2x plus 7 because it's its own tangent line. It is its own tangent line. So now we're going to go back through and X that thing out. And then we're going to go up and we're going to try another one. So we have, let's get bigger. All right, so we have this one. So now what do we have? We are starting with a parabola. What we have is an upside down parabola that's going to hit at 0 and 4/7 or 7/4, whatever. So that's basically what it looks like. So at the point negative 2, negative 30, which is way down here, we want to find the equation of the tangent line at that point. So we need a couple of things for the equation of a line. We need to know the slope and we need to know the y-intercept. So we're going to find slope first. So we have, hang on, go back to, ooh, no, I don't know what I just did. All right, still learning. All right, so what do I have? I've got the limit as h approaches 0 of f of x plus h. So 7x plus h minus 4x plus h squared minus your original function. So I'm going to erase all this trash. So minus my original function, which is 7x minus 4x squared. Okay, all over h. So on this one, we're going to distribute. So we've got the limit as h approaches 0 of 7x plus 7h. And then remember that this is x plus h times x plus h, which is going to give us x squared plus 2xh plus h squared, but I'm going to distribute the negative 4. So that gives me a negative 4x squared, a negative 8xh, and a negative 4h squared. Okay, so I distributed, I got an x squared plus a 2xh plus an h squared, but then I distributed through a negative 4. Then I've got a negative 7x plus 4x squared all over h. And now I can start reducing stuff. So here's a 7x, here's a negative 7x, here's a negative 4x squared, here's a positive 4x squared. Everything left has an h. So we're going to take the limit as h approaches 0 of, reduce this one, the 7h over h is 7. The negative 8xh over h is just a negative 8x. And the negative 4h squared over h becomes a negative 4h. And now I can take the limit. So wherever there's an h, it's going to go to 0. So he's gone. So here's what you just found out. You just figured out that the formula for slope for any point, any single point on this curve, so it's the slope of the tangent line, or it's the rate, or it's the formula for instantaneous rate of change, is 7 minus 8x. So instead of f of x, or sorry, instead of m equals y2 minus y1 over x2 minus x1, our formula for slope for this specific curve is this. Okay, so where do I want to evaluate it at? I want to evaluate at -2. So 7 minus 8 times -2 is going to be 7 plus 16. And 7 plus 16 is 23. So my slope is 23. Well, now can I find the equation of the tangent line? So do I know the slope? Yes, I do. I don't know how to erase all this really quickly. There's got to be an easier way than this. All right, so anyway, we'll use a different color. We'll use purple. We'll use green. We'll use green so you can see it better. All right, so do I know the slope? Yes, I do. Do I know a point on the curve? Yes, I do, because I got an x coordinate and a y coordinate. So if I have y equals mx plus b, do I have a y coordinate? Yes, I do. It's -30. Do I know what m is? Yes, I do. It's 23. Do I know what x is? It's -2. And then can I figure out what b is? Or can I figure out where my y-intercept is? Okay, so 23 times -2 is going to be a -46. Okay, and then plus b, I'm going to add 46 to both sides. So -30 plus 46 is 16. So here's what I found on my original thing. First of all, what is your b value? I get y equals 23, and my b is at positive 16. Your y-intercept is at positive 16. Okay, so now what I would like to do is, there's got to be an easier way. Hang on, can I do this? Erase all ink. Wow! I told you there was an easier way. All right, what I had before was I had a parabola that looks something like this. Okay, I had a point here, and I had the tangent line here. So what you figured out was its slope was 23, and it hit the y-axis at 16. So you found the full equation of the tangent line. All right, so we're going to pause. All right, so I skipped one in your homework because you're actually going to use the same process here. It's just that this one gives you context, whereas the other one doesn't. So velocity of a ball. First thing that you need to know is when you do the limit process, the answer is the formula for velocity. So remember that velocity is instantaneous rate of change. So it says my position function, which is where I start, of an object moving along a straight line is given by s equals f of t. The average velocity, so remember average means algebra, is the average rate of change. Instantaneous velocity is my instantaneous rate of change, which means I'll have to do the limit process. Okay, so I'm given a position function. I am given this, okay? So that's what I need to work with. It says what is its average velocity. So I am given an interval from x values of 3 to 4. So if I were to graph this thing, it would look something like this. Again, okay? Except for that hits at 0. All right, so I want to know, this ball is thrown straight up. So the ball is going up, and then it's going to come back down, okay? Its initial velocity is 128 feet per second. So I've got 128t minus 16t squared. I want to know average velocity, okay? Average rate of change between 3 and 4. So what I'm going to find is a line that connects 2 points at 3 and at 4. And again, I'm just sketching this, so I don't even know if it's right or not. All right, so there is my line. I'm going to find the slope of that line. This is not the tangent line. It shares 2 points, so it's called a secant line. Okay, so what am I going to do? I'm just in algebra world. So I need to use, hang on, let me erase all this mess. I need to use m equals So I've got m equals y2 minus y1 over x2 minus x1. So for this first one, I'm going to use x values of 3 and 4. Okay? I will use x values of 3 and 4. So I know that if I shove in a 3, what's it going to get me? If I shove in a 4, what's it going to get me? So what I have is 128 times 3 and open. All right, so 128 times 3. And then I'm going to subtract off 16 times 9, because 16 times 3 squared. So minus 16 times 9 is going to give me 240. So if I shoved in a 3, I got 240. What that means is 3 seconds into this thing's journey, it's at an elevation or a height or an altitude of 240 feet. All right, so let's do it again. I'm going to shove in a 4 this time. So if I shove in a 4 into this equation, I get 128 times 4 is, and then I subtract off 16 times 4 squared, or 16 times 16, which is 256. Okay, so 512 minus 256 is 256. So 4 seconds into the journey, this thing is 256 feet in the air. So I want to know the average rate of change. So my average rate of change is going to be y2, which is 256, minus y1, which is 240, over x2, which is 4, minus x1, which is 3. So that's going to give me 16 over 1, which is just 16. So my average rate of change is 16. Okay, now you're going to do it again, but you're going to change these numbers. Okay, so I'm still going to use the stuff for 3 that I had, but now I'm going to get a little bit closer. So in other words, instead of 3 seconds to 4 seconds, I'm going to do 3 seconds to 3.5 seconds. So I'm working with this one. So if I shove in a 3.5, what do I get? That's a decimal point. If I shove in a 3.5, I get 128 times 3.5 is 448, minus 16 times 3.5 squared is going to be 252. Okay? So that should make sense, because at 4 seconds it was at 256 feet. Well, now I'm at slightly shorter time, so it's still going up, so it's not as high as it was. All right, so what do I have? I've got y2 minus y1 over x2 minus x1, and that's going to give me 252 minus 40 is 12, over, I've got 3.5 minus 3.0 is going to be 0.5. So when I do that division, I get 24. So my average velocity is going to be 24. Okay, so now we're going to try it one more time, and that one more time is we're going to get even closer. So if I use 3.1, I wish I could make this bigger. I don't want to erase all the ink. I just want to erase some of the ink. Okay, so there we go. All right, so I'm going to use y2, which is, I don't even know what it is yet. Hang on, forgot to keep erasing. All right, so what I have now is a 3.1. And so I've got 128 times 3.1. That is such a lie. 128 times 3.1. And I'm going to subtract off 16 times 3.1 squared. Okay? And that gives me 243.04. So 243.04. So what do I have? I've got 243.04 minus 240 over 3.1 minus 3 is going to give me 3.04. Yeah, damn it. 3.04 over 0.1. Okay? So divide that by 0.1 and I get 30.4. So you'll notice that the closer my increments are, the faster it's going. Okay, because it's got to cover more distance. So what's my instantaneous velocity? So we're going to come back and finish this problem in a second.